So for part C here, same idea. We now want to find the simplified equation for f of x minus 1, right? And like always, right, if we wanted to find f of 1, what would we do? We would put in a 1 wherever we see an x, right? If we wanted to find f of 7, we would put in a 7 wherever we see an x. Well, now we want to find f of x minus 1. So what are we going to do? Wherever we see an x in the original equation, we're going to put in x minus 1. And by doing that, we'll be finding f of x minus 1 and on our way to getting the simplified equation for that transformation. So f of x minus 1 is going to equal, okay, originally I had an x squared. I'm going to put an x minus 1 and square it. Okay, plus 3 times x. So for this transformed equation, we'll do plus 3 times x minus 1. And there we go. That is the equation of the of the transformed function, right? It's not simplified yet, though. Simplification would involve expanding all this out and collecting like terms, right? But now we have an equation for f of x minus 1. We've just got to simplify it. So x minus 1 squared means x minus 1 times itself, right? Here I can just distribute the 3 in, so 3x minus 3. And then here I'm going to have to FOIL, right? Making sure both of these terms get multiplied by both of those terms, since we're multiplying the entire binomials by each other. So x times x gives me x squared. X times negative 1 gives me negative 1x. Negative 1 times x gives me another negative x, and then negative 1 times negative 1 gives me a positive 1. Now I just need to collect like terms, and we will have our simplified equation. So x squared minus x plus 3x, so that's minus 2x here, plus 3x, that's going to leave me with plus 1x, right? Negative 2x plus 3x, so plus 1x. And then plus 1 minus 3 leaves me with minus 2. And there we go. That is now the simplified equation for the graph that you would get if you took this thing and applied this transformation, right? In other words, shifting everything 1 to the right because our h is positive 1, right? So if you took this graph, shifted everything to the right by 1, it would look like this graph. And this is, again, why our function notation is so powerful. These are exact instructions on how to take this equation and transform it into that function having been translated 1 to the right? These are the instructions. It says instead of f of x, do f of x minus 1, and you'll achieve that transformation. So all we had to do was wherever we saw an x, put in that x minus 1, right? Just like we did over here. Instead of the x, we put in the 2x. Alrighty, for D here, I see a couple things going on, right? We can see that we have a B value of 2 and we have a K value of 1. So multiple things are happening, but again, we can break it down into chunks here. There's essentially 2 things we need to do here, right? These are the instructions. Instead of f of x, we want f of 2x. So anytime we see an x in the original equation, we're going to replace it with a 2x. That's what finding f of 2x is. Once we've done that, we then need to add 1 to the result, right? This is saying find f of 2x and then add 1 to whatever that is. So first, let's just get f of 2x. F of x is x squared plus 3x. So f of 2x is going to be, well, 2x squared plus 3 times 2x. Right? Again, just putting in 2x wherever I see an x in the original function. That's what this is telling me to do. So if that's f of 2x, what's f of 2x plus 1? Well, it's this plus 1, right? So we can start writing out our equation. We'll still need to simplify it some more, but we're going to have 2x squared plus 3 times 2x plus 1, right? This is f of 2x plus 1, plus 1. Okay, so now let's just simplify a bit. 2x squared, remember, all of this is being squared, right? X was being squared, so now 2x is being squared. Not just 2, not just x, but 2x. So that's 2x times itself. 2x times 2x would give us 4x squared. Plus 3 times 2x is 6x plus 1. And there we go. I actually think we don't even have like terms to combine. There's our simplified equation. So notice again, what did we do there? We broke it down and we followed what these instructions are telling us, right? They're saying replace x with 2x in the original function and then add 1 to whatever that gives you. So we replaced x with 2x, right? And then we added 1 to the result of that. And then we simplified.